Alright, so we are going to talk first of all about properties of limits, and this just lets us know some shortcuts that we can use once we see limits. And so let's just say I've got some real numbers b and c, and I also got a positive integer n, and f and g are two functions with the following limits. As x approaches c, the limit of f is L, and as x approaches c, the limit of g is k. So let's talk about a scalar multiple. And this means, let's just say you've got f, but you've got this number in front of it. And do I need to distribute this number before I can take the limit? And the answer to that is no. You can actually move this limit inside of the b. And you can take the limit first. Then you can take that limit and multiply it times b. What that's going to do is going to keep your numbers smaller before you multiply times b. So you have the right to take the limit and then multiply through by that constant. Second property, but by the way, most of these are almost common sense. They just make sense. Second property is sum or difference. Is if I have two functions being added or subtracted together and I want to take the limit of their sum or difference. Instead of adding or subtracting the functions together, I can take the limit of each function separately. So I could do the limit as x approaches c of f, and then I could add or subtract that to the limit as x approaches c of g of x. So I don't need to simplify two functions first. I can just take the limit of one plus or minus the limit of the other. Same thing works for product. If I don't want to multiply two things together and then take the limit, I can take the limit of one function and then multiply that times the limit of another. This is going to really cut down on some of the algebra that we have to do. The same thing works out for a quotient, provided that the limit as x approaches c of g of x does not equal 0 anyway, because we can't have a 0 down here. But we can also do the limit as x approaches c of f, and then we can divide that by the limit as x approaches c of g. So we can take the limit of the top and the limit of the bottom and then divide those numbers. Now I'm going to go back and actually do those. And the power rule says if I got a function to a power, I can take the limit of the function first and then raise that limit to a power. So let's go see, oh yeah, and the composition function. If I've got a function inside another function and I want to take the limit, I can move the limit inside of f as well. So let's go up here and get some actual examples here. I've got the limit of f is L and the limit of g is k. So in this first example, this would work out to be b times L, whatever that number was. And number 2, this would work out to be L plus or minus k. And on the product, this would be, what is that going to be? L times k. And on the quotient, this would be L divided by k. And on the power rule, this would be L to the n power. And then on this composition, the limit as x approaches c of g. That was my L, right? Let me go back up here. No, that's k. All right, so the limit as x approaches c of g is k. I get down there. There we go. So this is going to be f of that answer k. Okay, let's work one-sided limits. One-sided limits are going to be restricting your view from one side or the other, and they're going to have this little exponent. First of all, I'm going to tell you the numbers at which f is discontinuous and explain why. This is -4, -2, 0, 2, 4, and 6. That might be hard to see. That's -4. Okay, so at -4, what do we have? Why is it discontinuous at -4? This is a removable discontinuity, and I'm going to abbreviate that RD. At -2, we have a jump discontinuity. I'm going to call that JD. And then at 2, we also have a jump discontinuity. And then at 4, we have you can call this an infinite discontinuity because this graph on this left-hand side is going down to infinity. And so we've got almost like a vertical asymptote right there. So I'm going to call that an infinite discontinuity. if you wanted to call the jump discontinuity, I don't guess I would argue with you too much there. Okay, so is that right? 1, 2, 3, 4 places that we have discontinuous. All right, now let's find the limit. Now, one-sided limits always have an answer. So let's take a look at this. As x approaches -2 from the right, this, you see that little plus sign on that -2? That tells you that this is a one-sided limit. So you have to restrict your view from one direction. From the right means from values bigger than -2. So that means I'm approaching -2, but from this direction right here. I'm not even looking to the left over there. I don't even want to look over there. Just from the right, what is my limit? And as we're approaching -2, from the right, my y value is approaching 2. Let's do another example. What about 4 from the left? Well, here is 4, but we don't want to look from the right. We want to look from the left. So where is this heading? On the left-hand side of 4. This is the left-hand side. From the left, where is this heading? That's heading down towards -infinity because it's going straight down. What about 2 from the left? Here's 2, but I'm only looking on the left side. Don't forget about the right. 2 from the left. The negative exponent up here on the 2 means from the left. So from the left, as we approach 2, this y value is 1. Now what about limit as x approaches 0? This is not from the left or from the right. So this is where we have to look from both directions and make sure it matches. So here's 0. I have to look from the right, and I also have to look from the left. And I have to make sure they're approaching the same y value, and they obviously are. And that answer is 4. Let's answer a couple other questions here. Does f of -4 exist? Well, here's -4. Is there a filled-in circle somewhere up or down from -4? Do you see a filled-in dot? Yes, we do. It's right there. The answer is yes, and on top of that, it is equal to 1. f of -4 equals 1. Does the limit as x approaches -4 of f of x exist? Well, here's -4. The limit is to the left and to the right. So from the left and from the right, are we approaching the same value? Yes, we are. And as a matter of fact, I could tell you that the limit as x approaches -4 of f of x is equal to, what is that y value? Looks like it's 2. Another question that's not asked here is the function continuous at -4? And that answer is no. And why is that answer no? Because this value does not match that value. Alright, so let's just take one or two more examples here and I'll be done. State the intervals on which g is continuous. Here's this graph of g. We are continuous from -4 to -2 because we're good all in that interval. But at -2 we got that little discontinuity. There's a jump discontinuity. Then union with -2 to 2 because everything's good from there to there. Union with 2 to 4, and that looks like we've got an infinite discontinuity right there. It's a vertical asymptote. 2 to 4, and then union with 4 to 6, and then union with 6 to 8. And I'll do one more one-sided limit to make sure you understand this, and so I'll be quiet. The limit as x approaches -2 from the right. So here is -2. From the right means we're coming in from this direction, from the right. And what is that y value? That y value is -3. Okay, well, I will see you guys tomorrow.